Hello. Earlier today, you heard Kevin talk about how Windows 10 is a great OS for all types of developers, no matter what types of tools you use, and no matter what type of development you're doing. My name is Stacy Durr, and I'm going to dive a little deeper into what's new for a few different types of developers. So let's start with desktop and UWP developers. Visual Studio 2017 is simply faster. It's got faster startup. Your code builds faster. Actually, if you want to be more precise, it actually links faster. So with FastLink, if you see the chart on the side of the slide, that shows you the difference with if your link time with FastLink off, on or on, off. Also, when you go to debug, then your symbol loading is faster. In addition to being faster, Visual Studio is more productive. You can point VS to any folder and just kind of get started. Build, debug. You don't necessarily have to have a project or a solution to get work done. For example, if you're working with Node.js or Python. Also, you've been asking for this for a while. With the Creators Update and VS 2017, you can have side-by-side SDKs. So this means that you can experiment with some of our new features while still having your normal production SDK all ready for your use. VS 2017 also has better refactoring support and my favorite, XAML edit and continue. Now, I know Kevin showed you this, but it's so cool. I've got to show you it again just really quickly. All right, here I have a super simple app. And you know what? Kevin showed you a frog. I'm going to show you an adorable kitten. So, but some people are cat people. Some people maybe aren't. So let's see. We're going to select this image. Now, this is a super simple layout, so I kind of know what element this is. But in case it didn't, if it was a more complex layout, I can go to the live visual tree. And here it's showing me the image. And if I right-click here, I can say View Source. And then bring my source window back, and it's shown me this image here. So I'm going to change this from a kitten to a dog. And there you go. I didn't have to save. I didn't have to stop at a breakpoint. I didn't have to rebuild. Quick, easy, and you also get to see animated GIF, which is always fun. All right, back to the slides, please. One of our goals as a developer platform is to make common things easy. So one of those common things is local data storage. SQLite is a great open source project that helps with this. And in the past, you could use it on Windows, but you had to package it up with your app. Starting in the anniversary update, we included SQLite in the operating system, and then we revved the version. So we've revved the version for the Creators Update. So you're like, why am I talking about that? That was last release. What about the Creators Update? Well, I told you already that we upped the version, but also we just published a great blog post, which I've linked to there, about how to use SQLite in UWP apps. So I suggest that you go try it, and it gives you a great walkthrough. Another thing that we've tried to make easier in Creators Update is globalization. So CLDR is a set of internet standards for date, time, all sorts of locale things. And then ICU is an open source API set that uses those standards. So starting in the Creators Update, we're now shipping ICU with Windows. That's going to greatly increase the globalization API support that we have and also the locale data. And you can use it on all of our platforms now because it's part of UWP. Speaking of all of our platforms, one of my favorite tools for debugging on other platforms is the Windows Device Portal. You can deploy and debug your app on multiple devices. So for example, if you're developing for a HoloLens, you don't have to, every time you make a code change, necessarily go put the HoloLens on to redeploy the app. You can just do the simple stuff from your desktop. So with the upcoming Xbox release, we have some additional WDP capabilities in Xbox. So the first is that we can do process lifetime from the home screen there. You can not just install your app, but you can also suspend and resume it. So it makes that easier to debug. There's also some additional options for installing your application, not just the AppX, but you can use it loose files. You can point it to a network share. And then my favorite, you can set up fiddler tracing on your Xbox, all from the comfort of your desktop, so that you can debug your networking calls. All right, speaking of Xbox, that reminds me of games and gaming developers. One of our goals in the Creators Update was actually to make Windows 10 an even better operating system for games on the desktop. Xbox is amazing, sure, but what about people who like to game on their PCs? So DirectX 12 is the way that you typically do games. And it's a great API, and it abstracts away a lot of the vendor-specific differences. That's great, until you want to actually use one of those vendor-specific things. So in the past, we didn't allow you to use some of the proprietary GPU-specific features, for example, high dynamic range. With the Creators Update, any app can call extensions by AMD and NVIDIA. No restrictions on store apps, no questions asked, and it's retroactive to apps that are targeting the anniversary update. In addition to being fast, 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 one of the things that games really need is predictability. You don't want whatever's going on in the background, for example, I don't know, your email's syncing, you have Facebook up, something like that, to mess up your frame rate when you're just about to win that level. So game mode is something either users can turn on with WinG, turn it on and off, or developers can request their application is always in game mode. And it gives you a more predictable set of CPU and GPU resources. All right, so we've talked about using DirectX 12. What happens when you actually need to debug that? Xbox had a great tool called Pix for this that just had some really deep ability to debug your GPU and your DirectX 12 calls. But there wasn't really a similar tool on desktop. So just a few weeks ago, we announced that we have brought Pix to the Windows desktop. And we knew it was cool. But we thought it was cool for a fairly small subset of people, primarily AAA game studios, most of whom the Pix team was already working with in their beta. So we announced it publicly, and wow. There were news articles, there were tweets. Everybody was really excited about it. So we kind of put on our thinking caps, and we're like, maybe people are going to use it for more things than they thought they were. Maybe we should show them more about it and let you guys figure out what awesome things you can do with it. So to show us more about Pix, please welcome Peter Torr. Thanks,
Stacy.
All right. So Peter, tell us, what is that enormous machine for? I don't know if you can see it on the live stream, but Peter has a very large machine here that he had to cart over from his office.
Yes, so luckily I had some help, but this is an Alienware machine here. This has got a GTX 980 graphics card, a Core i7 CPU. So it's a pretty beefy machine, so we can do a lot of cool things with this machine. We could debug Gears of War 4, for example, or Halo Wars 2. We're going to show you something a little simpler today. But also, as you mentioned, Pix, which we'll see in a minute, isn't just for AAA game developers. You could be developing a VR solution. You could be doing, say, a 3D modeling or a CAD-CAM type application. Anything that's really pushing the GPU and you need to focus on performance or the correctness of your graphics, Pix is a great tool to go use. So let's go ahead and look at what Pix looks like on this machine. So as I said, we could go look at, say, Gears of War 4, but that's a complex and proprietary application. We're not going to show that to you today. What we are going to show you today, though, is an open source DirectX sample that Microsoft has called MiniEngine. And here is MiniEngine running. You can see right now I'm kind of inside this room in a castle. I can look around with the mouse, just like you can imagine. I can move using the WASD keys, etc. And there's all sorts of cool things in here. There's lighting, there's particles, etc. But what I want to do today is focus on a performance problem that we have with this particular application. And those in the room can see that this has a pretty smooth frame rate. You might think there's no performance problem with this, but there actually is. And what I'm going to do for this demo is I'm going to focus on this lion's head right here. And I'm going to pause the game for a second and scroll up here to our analytics about the frame rate. And you can see here that our GPU time to render this frame is about 10.5 milliseconds. And to normal people, that might seem fine, right? 10.5 milliseconds isn't very long. But to a AAA game developer, that's pretty bad, especially rendering a scene this small. And I know that this scene should be rendered in about half that time. And I'm going to use Pix to find out what went wrong. So I could launch this under Pix and then go ahead and do a capture, but I already have one created previously. So I'm going to go ahead and switch over to that. And so here we have the Pix tool. And what Pix has done is instead of debugging your entire application like you would do, say, in Visual Studio, Pix debugs a single frame. So here we see the capture I took earlier of this single frame of the game. It's that same lion's head that I was just looking at. And we can do cool things in Pix, like here we have a representation of the 3D mesh that was used to render that lion's head. I can see how it appeared in the final output. I can go and I can look at the texture that was used. I can look at the normal map for lighting. I can do all sorts of cool things with Pix. But we're not going to focus on the graphics today. We're going to focus on the performance. So let's put that away for now. And I'm going to go to this events view. And what this does is this shows us everything that was done in order to create that single frame. So there are a bunch of steps that were taken to create this frame. So we had to render the scene, we had to do some post effects, we had to render the UI, etc. And also, for each of these, we have an execution duration. So scene render took almost 10 milliseconds, post effects took under a millisecond, etc. So we get this great timing information from Pix. And these other entries are noise in my 10 millisecond frame time. So I want to click into scene render and see which of these particular things was taking up all that time. And I see here that there are two items that are taking about half the time each. So one of them is generate ambient occlusion, which takes about 5 milliseconds, and one of them is main render, which takes about 4 milliseconds. And at this point in time, I could take a guess about which one is the slow one. But we all know when it comes to performance analysis, taking a guess is usually a trip to Pain Town, right? We don't want to guess and make assumptions. We want to go to the data and figure out what is slow and why. So for that, I'm going to pull up this section here and switch over to my timeline view. And what we see here is a timeline of work that was happening on the GPU. It is correlated to these events that are up in the top half of the screen. And I can see, you might not be able to see this very clearly on the stream, but you can see here in the bottom left-hand corner of this timeline view, there are a lot of short blue lines all stacked up against each other. That's great. That means the GPU is doing a lot of work in parallel because each line represents one piece of work. So it's doing a bunch of work in parallel here in the bottom left. And as we move to the right, we see there's this big blue chunk here of work being done in parallel as well. So here the GPU is doing great as well, doing all its work in parallel. But I look here in the middle, and there's this section that's about 4.5 milliseconds with really just two things happening. One very, very long thing happening at the top and something else at the bottom. And so I know that that's probably where I should start looking for my performance problem. I didn't have to guess, was it the render scene, or was it the generate ambient occlusion, or was it the main render? I can just click on this line, and in my events view, it drops me straight down and says, under scene render, under generate ambient occlusion, under decompress and downsample, there is this dispatch call that's taking 4.5 milliseconds. And I know that that's too long. Dispatch shouldn't take that long. There's a second line down here, which is the next operation, which was a resource barrier. And resource barrier really is just telling the GPU to synchronize. And so it's only taking 4.5 milliseconds because the dispatch is. So now I know that this one API call, this dispatch call here, is what was causing me all that pain. And if I switch over to Visual Studio, you'll see I have quite a lot of files here in this mini engine. And I don't want to search through all of them, finding out which one dispatch call out of potentially many is the one causing the bug. So what I can do is, those labels inside the event viewer were actually labels the developer specified. So in Visual Studio, I can just do a search. I can go and look for decompress, and that's the string I need. And here we go. We've jumped right into Visual Studio, right into the line of code that we need. And you can see that here is decompress and downsample. It's inside the generate ambient occlusion event, so we know that we're in the right place. So from here, I can simply do an incremental search for dispatch, which was the API that was giving me a problem. And I can see here that whoever added this particular code added this set of parameters, this 8, 1, 1. And I know that's the wrong set of parameters. They shouldn't have used 1. They should have used 8. So I can just go ahead here, convert these 1s into 8s, rebuild and run the solution. And now when I go back down and look at that lion's head, we're going to have cut our frame time almost in half. So let's fly through the world, get back to our lion's head. And as we fly back up here, we can see that our frame time is almost cut in half, down to 5.8 milliseconds. Thank you. So this is just a very quick example of using the Pix debugger to find and fix a potentially complex performance problem in my DirectX 12-based application. But as we said, could be used not just for AAA games. We found people using it for all sorts of things. So you can go and download the Pix beta now. And if you go to blogs.msdn.com/Pix, you can find the announcement. You can find links to how-to videos and other information about Pix.
Great. Thank you, Peter. All right. You'll notice if you didn't catch the URL that Peter was saying, I linked to it down there. I have a short link to it on the slide here. All right. So graphics, great. IDEs, great. But there's a section of the world who's really a little bit more command line. You know, some people like skiing vacations. Some people like beach vacations. Some people like command lines. So to tell us more about what's new in the world of Bash and the Windows subsystem for Linux, please welcome Rich Turner. Hi, Rich.
Thank you. Let me step over here. So let me just close down this previous demo. Okay. The command line. A beautiful thing.
It is great. So what's new in Bash land, Rich?
We've had quite a ride over the last year. It was only end of last March that we unveiled Windows Subsystem for Linux to the world for the first time, which gives developers the ability to run Linux command line tools, applications, compilers, and build tools, and so on Windows without having to have a VM or anything along those lines.
So I remember you guys got some really positive feedback, but I also remember that at the time you were pretty clear that there were gaps.
There were gaps, absolutely. When we released the Windows Subsystem for Linux and Bash on Windows feature last year in the anniversary update, we released it under the condition that this really was a technology preview. There were known issues. We hadn't yet finished all the work we wanted to do to be able to run the majority of the developer tools that people wanted. And we wanted to be able to get it into developers' hands. We wanted to be able to get it into the hands of developers so that we could learn from them what worked, what didn't, and so on. We've gotten a huge amount of feedback, as you said, from our community, and a very big shout out to our community who have run their tools and their favorite applications on Bash on Windows and fed back lots of bug reports and helped us actually find and triangulate down on the sources and the causes for a lot of those issues, which has resulted in a huge number of improvements to both the Windows console and to Bash on Windows for Creators Update.
So, for example, what works now that didn't used to work?
So when we shipped the anniversary update, we were able to just about run simple Node and Python and Ruby applications where you really struggled to run Java, for example. Now we run the vast majority of developer platforms that you want to use, from Ruby to Python to Node to Java, C++ and C, and so on and so on and so on. Even things like Go, Rust, even Elixir works.
How about services, say MySQL.
Well, they're pretty essential, right? When you're building an application, you want to run it and test it locally. You want to be able to get access to data. So MySQL now works. Postgres support came in very recently. We can now support Apache and Nginx as well, so that you can run your websites locally on your machine, again, without having to deploy VMs and go through that overhead.
Great. So I hear you have some cool console improvements.
We do. We've made a number of improvements to the console in order to provide a really great user experience for Linux developers working in the Windows console. Key amongst those features really are dramatic improvements to the depth and sophistication of our support for VT sequences, which are the inline codes that get generated as part of the output text from a Linux tool that allow them to set color, draw lines, et cetera, et cetera. So one of the key advancements that we made was, for example, to update the Windows console to go from being able to support 16 colors to 16 million colors. And a bunch of other improvements, including mouse support and all kinds of things.
Mm-hmm. Well, some people say console demos are boring, but I don't think these guys think so. So can I see some of those things you just talked about?
Absolutely. Let's take a look. So color support is something that was very popular on the forums and in the discussions we were having with our community. Here's a simple script, a simple shell script that that renders a 24-bit color gradient set and allows us to see things in beautiful, glorious color. And I can do crazy things like have beautiful rainbow-colored listings, which is file listings, which is always entertaining. And where would we be if we didn't find out what my day is going to be like? You've seen me do this before, but now we can do lolcat. Now we can do Fortune through Cowsay in color as well.
Not just a cow, but it's a cow with color.
It's a cow with color.
That's important.
What could one not like about that? Right?
All right.
So that's some of the improvements in the console. We've also, as I said, massively improved our VT sequence support. And for anyone who's ever used Midnight Commander, which was Miguel de Casa's original first ever open source project, we now render rich text-based UIs as well.
So I know that name, right? That's
Yep.
the guy who wrote GNOME and who's the co-founder of Xamarin?
And created Mono as well, yeah, absolutely.
All right, nice.
So Miguel's baby is now running on Windows once more. So that was a nice thing to have, and now the vast majority of text-based UIs that Linux applications can render, we can render with high fidelity and high accuracy as well.
Awesome. What else is new?
So on the WSL side of things, we've made a ton of improvements, and the team have really gone to town over the last 9 months or so, really adding a ton of capabilities to WSL's internals to be able to support and run more and more and more Linux applications, compilers, linkers, even debuggers and things. It's amazing the range of things that we can do right now. One extra thing actually I'd like to throw in here is that if we go to, for example, in Bash on Windows, we can now, we were always able to navigate into the Windows file system. And what we can now do is navigate into Windows file system. So here is, we're looking at and I'll move this up the screen a little bit for those in the audience. This is a folder on my D drive of my Windows file system, accessing it from Bash on Windows here. And I can go and look at, for example, the source code to the shell script that we were just running just now. Now, Vim is a great thing, and everyone loves Vim, even Emacs users, I'm told. But not everyone likes to use Vim. What if you wanted to open this file up in Notepad, for example? All right?
Cool.
This was a very, very, very popular ask. We obviously clearly need to do some work on Notepad to bring it up to date.
What, Notepad isn't your text editor?
It is not my text editor of choice, although it's still an enormously useful tool for just quickly looking at a bunch of text if you're not someone who wants to look at it in the command line. So that was a great new feature. But we've also we've added things like, for example, the file change notification support, which is important for Node developers who might be sitting in Vim in one Bash console or even editing the files within, say, Visual Studio Code. And when they save those files, they wanted the file system watcher to recompile their website so that they can see the website changes very dynamically within the web page that's sitting alongside their editor. We've now got that support as well. So there's just tons and tons and tons of improvements that have come with Bash WSL. And if it's something that you looked at previously that maybe didn't quite scratch all your itches and run all the things that you wanted, you should really take a look in Creators Update, because I think we'll be able to run the vast majority of DevTools that you're interested in.
All right. That sounds pretty good. What if maybe, I know this is not the thing I should say to command line developers, but what if maybe you didn't want to use the command line?
Absolutely, and some people do love the command line. Some people love Emacs. Some people love Vim. The Emacs guys are wrong, of course, but that's a religious war we won't want to get into here. But a lot of people love IDEs. They love sitting inside something like a Visual Studio that gives them IntelliSense and integrated help and code scanning tools and debuggers and all manner of other tools, all within one nice environment. So the Visual C++ for Linux team was actually released just before we announced Bash last year. And they've released a tool set that allows you to create a Visual C++ for Linux project, to pull all your C++ code within that project, and then to take that code and build and deploy it to a Linux VM or physical box, for example. Now, I've been wanting to demo this for quite a while, and we finally got all the bits and pieces necessary to make this work. What this is going to do is take this C++ application and deploy it to your local Bash WSL environment and build it and run it there.
Really?
Okay? No VMs.
I'm not sure I believe you. I think I'm going to have to say, show me.
I wouldn't believe me either unless I saw it working. So to make this work and to demonstrate this, I created a very, very simple little Hello World application. Main just calls say hello to the world, obviously in this particular case. And say hello function just writes out some text to the screen. Great. Now, this is a Linux application. So if we were to take a traditional approach to this, we would try and figure out some way to get all of the Linux headers and libs into Windows and somehow cross-compile the bits. And that would be really, really tough and tricky to make work reliably. But what the Linux for C++ for Linux team have done is they create an SSH channel to a target Linux instance and deploy the code via that SSH channel, build the code via that SSH channel inside the VM or the target machine, or WSL in this case, and allow you to generate the genuine Linux binary over there in the Bash environment.
Okay, so I'm going to go from Visual Studio through SSH and then be building sort of natively.
Building using the native Linux command line compiler tools, linkers, and so on against the native SDK libs and include files within the Linux instance itself.
All right, let's see it.
So let's rebuild this, and I'll move the output window up just a touch. Okay. Let's rebuild the solution. So you'll see here that the output window is indicating that the target is being cleaned, then the files are being copied, then the files are being compiled, and the files will be linked, and the output of that will be a real Linux binary.
Okay, where is it going?
So let's have a look over here. When you build a project in Visual C++ for Linux, it creates in your home folder a projects folder. I'll move this up here a little bit for people in the room. This projects folder is where the output, the files themselves to be built and the output from the build process are copied. So if I go over here and take a look at projects, there's a hello folder. If we go into hello, here, let's clear that. Here are the binary output folders and the main.cpp. So if we go into Vim, because Vim is better, obviously, we can see here is the original source code that was in Visual Studio. Great. Now, if we go and take a look at bin x64 debug, we'll see there's a hello.out file. This is a real, genuine Linux binary file.
Really? How do you know?
Because if we run file on hello.out, this shows us some of the information from the file's header. This is the Linux GNU file tool, and this shows us this is a real, genuine ELF64 binary. This is not a Windows PE executable file. This is a real Linux file.
So because it's real Linux, you'd have to like go run it on a remote Linux box or something like that, right?
You could. You could actually literally pick this up and go and drop it on an x64
Okay.
Linux box. Or you could run it because we're in Bash on Windows here, and we can run Linux applications. So if we go hello out, there's
Nice.
the output from the code that we saw earlier on.
All right. Okay.
So that's great. We can run the tool that we've just compiled using Visual Studio in Bash on Windows Inception. We should really have called it Inception, I think. So I have a question for you. Now, you're a hardcore geek, and if this code had a bug in it, which it doesn't because I wrote it, clearly, if this code had a bug in it, how would you go and figure out what went wrong?
Well, I would just go to Bash and launch GDB.
Right, absolutely. But for mere mortals like me, I might prefer to go and debug this code from within Visual Studio.
You're going to debug from Visual Studio through SSH
Yes,
to GDB.
yes,
Okay.
yes.
This I want to see.
So this is one of the other really cool features about Visual C++ for Linux is that the guys have hooked up a mechanism that integrates the Visual Studio debug engine with a protocol handler that essentially talks via SSH to a target Linux instance and drives GDB under the hood as if you were doing it manually. It uses it to gather stack information, variable information, and so on, so it can populate the UI, and we can single step through code and so on.
All right. Prove it.
Should we see if it works?
He's not sure I really believe him.
So, as you can see up here at the top of Visual Studio, where you would normally see your debug button, it's been renamed Remote GDB Debugger. And when we hit that, within a couple of seconds, it's just checking whether it's been built or not. It's been built, so it doesn't build it again. And within a couple of seconds, we drop straight into the debugger in Visual Studio here at the breakpoint that we set on the side. Have we really broken in?
Have we?
Have we? Wouldn't it be great if, for example, we could single step into things? There we go. So we've just single stepped into say hello. We can inspect the parameters passed into this call. We can go and explore all of the objects. We can use the debug windows to look at the stack, for example, and the locals. Here's the locals inspector inspecting the same data. And so we can actually use all of the Visual Studio tools that you would normally use to examine variables, properties, et cetera, and set other breakpoints, or continue to single step through your code and figure out what went wrong, and then fix your issue.
Awesome. Well done. I don't know. What do you think, guys? Do you think that we should pay these guys their salary? Do you think they've earned it over the past 6 months?
Yeah, the VC team really did a great job with this tool set, and it worked so smoothly once WSL was able to run its side of the conversation. It worked so smoothly and so well. It's an amazing tool.
Great. Thanks very much, Rich.
Thanks very much. Thank you.
All right, so we've just seen some really cool things in Bash and WSL. And there's a link on the slides to get some more information. Earlier today, we heard about new things in VS 2017. We heard about additional things that UWP developers can do, that gaming developers can do. So what is next for all of you? Well, download the SDK, download VS 2017, join the Windows Insiders program to get the builds today if you aren't already. Give it a try and send us some feedback. Tell us what you like. Tell us what you'd like us to do differently next time. Thank you.